Hi, welcome to Basics of Special Relativity, Lecture 3, Overview of the Weirdness of Special Relativity. The starting assumptions of special relativity, particularly the constancy of c, lead immediately to some very weird effects. These effects are very non-intuitive, so it's good to have a rough overview of them before we get into the mathematical details. We're going to give a flavor of some of the weird things that happen in special relativity. All of the topics mentioned here today will be covered in detail in the upcoming lectures. And there's no math in today's lecture. The first effect we'll cover is the relativity of simultaneity. Let's say an observer in one frame observes two events which occur at different places but at the same time. They report these events as simultaneous. So here we have an observer who sees two events happen at t0. Okay, now let's add another observer moving relative to the first one at velocity v. This person may observe these events occurring at different places and at different times. So they see one of the events happen at t'1 and the other event happen at t'2. Okay. The next interesting effect is time dilation. Let's say two observers have identical clocks. The two observers are moving relative to each other with a uniform velocity v. Each observer will measure the clock in the other frame as running more slowly than their own. So in this picture, each of these observers thinks the other observer's clock is running slow. Note that it's not that each observer thinks the other's clock is behind. Each observer thinks the other's clock is running slow. For example, each might observe the other's clock only advance 57 minutes every time their own clock advances an hour. Additionally, if two observers start from the same location and one of them goes away on a trip and comes back, the two observers will disagree on the time duration of the trip. The one who went away will say the trip was shorter. This is called the twin paradox. Okay, next, let's talk about length contraction. So this time, let's have the two observers carrying not clocks, but identical measuring sticks, aligned with the direction of the relative motion between their two frames. Both observers will measure the length of the other observer's measuring stick as shorter than their own. So in this picture, we have two observers. They each think that their meter stick is 100 centimeters long, but they also both think that the other person's measuring stick is only 99.5 centimeters long. Now, these effects don't seem to jive with what we see in daily life. The reason is that these effects are really small unless speeds close to the speed of light c are involved. As an example, a passenger jet flies about 900 kilometers per hour, about 8 times 10 to the minus 7 times c. For this speed, the effects of time dilation and length contraction on time and length measurements are about 3 times 10 to the minus 11%. These effects are impossible to see without high precision measurements. Okay, so hopefully that gives you a rough idea of the weird effects we run into in special relativity. In the next lecture, we'll pause to make a technical point about observations in special relativity, and then we'll get into these effects starting in lecture 5.